If you are building your own redstone computer in Minecraft or just want to simulate the functionality of a computer, it can be very helpful to write a little simulation program that simulates the functionality of a computer. Okay, I'm already repeating the stuff I'm saying. That's not good, but let's continue. Okay, this here is a code monster, but let's give a quick example of how this is working. Okay, let's compile. And here it's showing the values of all registers, the program counter. Let's make it full window. And here a little display. I am not quite sure what program is currently running. Down here is the input. Okay, it's a bad program I'm running. Let's change it to a good program where you can actually see something. Full size again. Start a program. Enter a value down here. And go. Yeah. Okay, now it should work. And click start a program. Enter the input and it's drawing a line. And the line is increasing by 2, which was the input. Let's give another input, maybe 5. And it's now drawing a line that's increasing 5. That's only increasing 1 on the y coordinate every 5 steps on the x coordinate. Okay, one last example. Let's type 1 and you see a line that is increasing 1 on the y-axis for every increasing x on the x-axis. Okay. Let's first of all talk about the functionalities of the GUI. As you can see, first of all, let's start a program. Now it's requesting an input. But after the input is requested, I want a program to halt, so I clicked on stop. Let's give a 3 as input, and now the program waits. There is one single line, which will execute the next line, and the next line is always shown up here on the top. Okay, let's make full screen. Here on top, the next line that will be executed is shown. Up here is shown if it's currently running or if it's in one single line mode. And here all the registers with their decimal values and behind their binary values, and down here the program counter, and next to the program counter how many calls have been done. Okay, if I now click through this, you see up here it's going through the lines and it's slowly printing a line with 3. Let's continue the program again and let's draw it finish. Perfect. So this is working. Let's talk about the things here more in turn. Okay, first of all, I have written a lot of debug because, yeah, you can see this code. It's a mess, and writing some debug lines is the only way to keep track of errors that occur. And the code is can basically be split into 4 parts. Part number 1 is the GUI. Yeah, if you want to create your own GUI, watch a tutorial. I have also watched a tutorial. After 3 or 4 tutorials, you understand a bit how JLabels and JFrames work, and you actually could be starting to enjoy the process of creating a GUI, but I think for most people it's just pain. I am not quite sure if it was pain for me or if I was enjoying it. Okay, the second part is here. The logic that controls if the program is waiting for input or just the logic in the background that catches exceptions, stores the last line, increases the program counter after every line, updates the GUI, and controls stuff like if the GUI or the entire program is running on auto mode or is running on the mode that you have to click the button to compute the next line and all that stuff. Okay, the third part is the assembly line. Here, the top part here will extract one line from the code, for example, this code here, and it will put this line into the assembly line. And here, okay, actually, I forgot one little thing, but I will talk about it later. The assembly line uses a switch token. The switch token allows me to have many different cases, and the cases depend on what is the first character combination at the start. I get the first character combination by taking the line this thing here has given us and putting a scanner on it and then querying the scanner to put the first character sequence into token. Okay, this token is now switched through all the cases, and if it is matching with one case, then it tries to execute this code. If something goes wrong here, an exception will be thrown, but that exception is catched, and then you can decide what should be done if an exception occurs. For my case here, I just printed that with the load function an error occurred. Okay, yeah, now you just, for all the different cases or opcodes or operations you want to support, you just enter here, for example, load, and that will it will scan the token line for the next token, I would say. In the case of load, on the top one here, it will find, it has first found load, then it will find R1 and R0. Okay, and then there's just some logic happening, and this logic is whatever you want your opcode to do. Okay, this is also then for adding, subtraction, and all the other stuff. Okay, one thing I want to talk a bit more about is branching and jumping. So that's the part I, at the beginning of the section, talked about. And that is that there, up here, I think, there is a token list created. And in this token list, at least I think it's up there. Collect tokens, let's look. Here is, okay, it's even before this logic here. Directly at the beginning of a simulation, all tokens are collected from the file. Okay, the file, this is a bad file for showing this. For example, this file. A token is something like that, part 3. And the target or the aim is to be able to jump to those tokens. But to be able to jump to those tokens, you have first of all to scan the file at the beginning for all those tokens and then store those tokens in, for my example, a hash map. Exactly, so that later while executing the code, if you find a token, you can just put the hash of this token into the hash map, and then you find in the hash map where in the program this token was placed, in which line the token was placed. So if you would look in the hash map for part 3, it would return line 57. Exactly. And this is the same thing for jumping. So if you jump to a token, it basically looks into the token list and searches the value the token corresponds to. Okay, another thing is printing a pixel. So that's just sending, it's here taking again the values from the registers, and then it's sending those values to the GUI, and into GUI somewhere down here is set numbers, the method, and it just sets at an index the value that was sent. Nothing complicated, I think. Okay, now let's talk about how does this actually work? How can it get a register? So let's repeat. The token line comes from top here, and a token line is an entire how do I say, a chain of 3 or 4 things written behind. So a token line would be load R4 and then those ones. And okay, to now get register 1, for example, let's go to load for load. Token line was already scanned for load. So the next thing that will be scanned if you scan token line, which is done by token line point next, is after load R1. So in the register R1 is stored. We now know that after load there comes a register, and after the register there comes a value. So token line point next stores a value, because as you can see here, after load R1 there comes a 0. Okay, this is done by the massive block down here, setrec and getrec, and it's working with another switch statement. So also it's checking for every register, and for example, if register, or for the getrec, for getting the value of a register, it just returns 1, and for setrec a register, setrec takes the register that is searched here in the string, and then the result that should be stored in the register, and then also by a switch statement it checks through all these cases if the string from rec is equals to some of these cases, and then if it finds one of these cases it executes what is written down here, and for case of register 1 it just stores the result that was sent to setrec in register 1. Simple. Then there is another part. Because computers work in binary, I have written those functions convert decimal to binary and convert binary to decimal. First of all, so that the binary values here can be converted into decimal. It's not completely necessary to do that, but it's much easier to, for example, for the addition here, to just type T1 plus T2 instead of having to implement an addition that actually works for binary. And there are also other cases, for example, if you want to print out a number, you also want to convert it from binary into decimal again. And yeah, some other cases. Okay. I know that was only a quick showdown and nothing like a real tutorial. I hope it still gave you an idea if you want to create your own little GUI or just a computer simulator. And yeah, I have nothing else to say. Bye.